All right, thank you. Thank you for the kind introduction. Am I supposed to see anything here or no? On this? No? Used to, okay. All right, so even the screen is tired, I guess, the last presentation. My real name is Parimal Kopardekar. That's why they call me PK, as you can see. I'm here to talk to you about air traffic management, airspace operations, where we have been, the kind of research we have been doing, and we are continuing to do that. And then we are adding certain things to our portfolio in terms of the new entrants, all the way to the urban air mobility, the drones, as well as commercial space operations. So we'll go through quick overview of air traffic management, then we'll talk about drone or UAS or unmanned aircraft system traffic management, and then we go towards urban air mobility and things for beyond how the current setup for air traffic management is not scalable and why we need to change towards new paradigm. So let's take a look at a video of what happens today. Let's see. Okay. What's this? How do I make this video work here?
I'll have them started.
Okay. All right. So this is how the current air traffic management system works. These are what you're seeing here is all the aircraft, East Coast, West Coast, number of aircraft flying, and at a time
We can't hear you from the microphone.
5,000 at their peak. This is the time in Eastern. I'm not sure you can see it. This is 5 o'clock in the morning, 6 o'clock, 7, almost 8 o'clock. You can see the busy East Coast. West Coast is still sleeping, getting ready. Now it's 8 o'clock on the West Coast. For uncontrolled airspace. So airspace is typically divided up in uncontrolled and controlled. So uncontrolled airspace is away from airports where not much commercial aircraft operate. So this is where general aviation by and large operate. But we start to use uncontrolled airspace as a beginning. And fundamental thing here that's different is the UTM leverages industry's ability to provide services, and we'll talk about what those services are. If you look at current air traffic control system, air traffic management system, everything is provided by government. So communications, tracking, surveillance, changes to flight plans, all that has to be approved or provided by government. So we are changing that model upside down. For UTM is under FAA's regulatory authority, we say, okay, we can actually leverage services from outside. So companies can create services, and we'll show you our architecture and services that you can create for trajectory, for weather, for terrain data, all kinds of things, communication. We can leverage services from outside the government. Industry can provide those services. That's fundamental shift. So UTM basically focuses, our research is on who does what from FAA to regulator to the, as a regulator, then operator and the service suppliers. What's the roles and responsibility? What are the services? What's the quality of performance for these services? And what kind of exchanges that need to occur among operators? Remember I mentioned that today air traffic controller for manned aviation detects the conflicts between two aircraft and then they separate them. Here we are doing that all automated way through data exchanges. So if you are operating in one airspace and I want to go into the same airspace, we are exchanging information to each other. There is no middle person. So that's sort of the idea here. So there's a lot of research that's going on, and if you want to know more about it, it's utm.arc.nasa.gov. And if you forget that, just do Google search on UTM and my name, and there's a ton of information you'll find. So fundamental operational assumptions, and these are important assumptions because they translate into capabilities and products that you might be interested in building. FAA still has authority, and FAA can still issue directives such as president is in town or any constraint in the airspace for security, safety reasons. They can issue those. But air traffic controllers are not required to actively control every drone. That's the fundamental difference between the manned aviation and unmanned aviation. FAA or any regulator has on-demand access to airspace users. So who is out there in the airspace? They can get that immediately. They can maintain the situation awareness through the US traffic management system, research prototype that we're building. The roles and responsibilities are defined here: regulator, operator, and service supplier. And FAA can institute constraints anytime you want. Fundamentally, safety is paramount. So what we are trying to do is, without burdening the current air traffic management system, we are trying to keep it safe. So the 5 principles, which is public safety has priority over other operators. Operator has complete understanding and awareness of airspace and the constraints. This principle alone can generate a ton of business opportunities. So in other words, how do you make sure that Walgreens wants to do, or Amazon or whoever it is, wants to do an operation in the airspace, what kind of information they need to have before they enter the airspace? You can create a basically trajectory model for them that's free of conflicts or free of terrain and bad weather and all kinds of tree lines and electric wires, all of that. So you have tremendous opportunity to say, hey, I'm going to be airspace provider, information provider. So a lot of opportunities here. Then drones and manned aircraft and drones stay away from each other. Another huge business opportunity for you to create sense and avoid LiDAR-based or acoustic-based or all kinds of different ways of detecting other vehicles in the sky and staying away from them. Drones stay clear of each other. That's another same thing. You know, you can use a number of technologies and algorithms to detect each other and stay away from each other. And then authentication schemes. Right now, FAA is actually meeting to figure out what are the best ways to remotely detect and track vehicles and identify them. So these principles then translate into services where you can generate your businesses. One is authentication, authorization, airspace configuration, creating dynamic and static geofences. Static geofences are for airports where you can go Dynamic geofences are for places where there is firefighting going on, so they change over time. Another huge opportunity is track and locate. How do you track vehicles and locate them? Once you let them go beyond visual line of sight, if you're in the visual line of sight operation, then you're doing eyeball traffic management. You're watching each other and staying clear of each other. Let's assume that that's perfect operation, which it is not, but let's assume that. Now you go beyond visual line of sight, then you have to electronically track the vehicles, and you had to make sure that you are where you said you are going to be. So that becomes very important. Now, how do you do that? So 55% land is covered by cell phones. What happens when there is no cell phone coverage? So yeah, people say, well, do you use cell phone? What about the 45% of the land? There are urban canyons for GPS and satellites and such. Well, what happens when you are in those? So satellites work well, in the border areas, or you have access to satellite, line of sight and such. But there are places it may not work. So then people talk about ADS-B. There are limitations about spectrum. So then you have an opportunity to say, hey, maybe I come up with a solution that combines all these technologies for tracking vehicles based on where they want to operate. Communication control, you can do cell phone-based comm or satellite-based comm. Wind and weather, very interesting, very important for this industry. Traditionally, our general aviation helicopters, gliders operate in that airspace. Their susceptibility to tolerate wind is very different than the winds. So we need a better wind prediction, better models. Another huge opportunity for small businesses to develop crafty ideas about how you actually come up with the prediction of the wind at the local level. Because these vehicles won't tolerate 30, 20 knot wind. Aircraft can. Conflict avoidance, another way to basically identify who is in the airspace and stay clear of each other strategically as well as tactically through sense and avoid or detect and avoid technology. Demand and capacity management. Now in the manned aviation, demand capacity management is largely done for air traffic controllers' workload in the airspace, on the ground, gates and runways. So there are three bottlenecks in the current air traffic management: gates, runways, and air traffic controller workload. None of those apply here because these drones are flying from everywhere to everywhere. I've been quoted in the media by saying every home has a drone and every home serves as an aerodrome, which is airport. And people say, well, are you crazy? Is this really going to happen? Well, it could happen. I mean, if that's the case, then how do you actually manage that? The demand capacity imbalance would happen here for different reasons. One is noise, second is spectrum, and the third is just visual noise. So auditory noise and visual noise. How many of people really want to have a lot of operations over their backyard? So there is going to be some acceptability limits of demand capacity. And then another huge opportunity for businesses is how do you detect contingencies? So national security, for example, 911 happened. Well, the cost of entry into airspace with drones is practically zero. How do you make sure that a bunch of drones are not going to some asset that needs to be protected? What kind of algorithms do we have? What kind of intelligence do we have? So that you say, hey, there's something going on here in the airspace and that needs to be mitigated. Huge opportunity for security. So then we divide up the roles between the operator. Operator is responsible for registration, communication, navigation, surveillance, where you can provide those services to them for a fee, training, qualifying, keeping away from all the obstacles in the airspace, avoiding incompatible weather, and the regulator is basically primarily in charge of setting up constraints and understanding some big problems if there are. So this is an example of the weather. Operator has a responsibility, but weather can be provided by third party. Different models can be provided. You can create sensor network in certain areas in the cities, suburbs, and say, hey, I'll provide you weather information, fee for service. So there is no unique approval necessarily, but this is going to be a key key input into making sure that the operations are safe and persistent. You want to be able to know that you are going to be able to deliver into certain airspace or go and monitor traffic, and the weather is going to be friendly enough that your operation will be successful. This is an architecture that I mentioned before. So this is entire UTM environment. This is the Flight Information Management System. That's the FAA side of the house. Any regulator, if you go to other countries, which will send in constraints and directives to all the operators and service suppliers. They can get information about any deviations or variation into the flights if needed. There will be a public safety and security agencies who can drop in the information. Operators can work with service suppliers, or they can be service suppliers themselves. If you have a fleet, you're likely to be one and the same. If most cases, if you are not going to manage a fleet, you just want to be end user, then you're going to subscribe to some services. So as you can see, there's a huge opportunity to be a service supplier or provide data for terrain, weather, surveillance, different types of performance, and such. We have 4 capabilities. So this is sort of aviation is all about safety and evolution. So we started off with capability 1, which is over unpopulated land, showing multiple operations can work. Second capability goes beyond visual line of sight with tracking. Third capability is manned, unmanned aircraft together. So V2V is another opportunity for small businesses to develop key technologies for extending the car-to-car V2V vehicle technologies into the drone space and then into the urban airspace, including the contingencies that I mentioned. So this is sort of an example where you can have multiple operations happening. The white line is the vehicle that's being tracked. Blue is the planned area of operation, and there's some buffer around it to be safer. Multiple operations happening at the same time. And we have different types of alerts, contingency alerts, if you veer off your path, or conflict alerts if you're going to be together with some other vehicle, any priority operations and such. So what the UTM system does is allows you to schedule and track vehicles so that you stay away from each other. The research platform, these principles that I mentioned, and then the features we have basically map with those principles that I talked about before. So some of the evaluations that are going to happen in technology capability level 3, which is one of the most challenging one, that will have vehicle-to-vehicle cooperative as well as non-cooperative aircraft. So huge opportunity for small businesses to develop tracking methods using cell phone and satellite and ADS-B or combination thereof, or something new totally altogether, beacon-based systems and such. Also detecting obstacles in the sky through LiDAR, acoustic measures, optical measures, and such. Communications and navigation, creating basically trajectories that are clear of conflicts, as well as reducing the risk on the ground. Lots of opportunities. So this is, I think, one more video here. Just show. How much time do I have? So this gives you an example of the UTM environment. You'd rather have a break with some music rather than me talking for 45 minutes. About the UTM is multiple vehicles operating simultaneously. Currently, there are FAA has Pathfinder programs where they are focused on one operator and one industry. So this allows you to operate at the same time, same place, beyond visual line of sight. So this is an example of geofence area for agriculture. This is one of those corridors over city or suburb where you can have drones flying. This is the challenging problem where the drones and airport had to keep away from each other, so the drones stay out of this zone, geofence, airport. This is one instantiation of UTM where everything is basically sent into the cloud and it comes back as a quick check that it works. We are kind of moved away a little bit from this architecture. It's still in cloud, but it's not centralized architecture anymore. It's more peer-to-peer. All right, now let's look at entire picture and you say, well, how do I actually get to the next level of operations, which is urban air mobility? So not just drones, but what happens when you have what people characterize as flying cars, although some people object to that term, but basically personal or smaller vehicles operating in the city environment. So clearly, the foundations here in any aerospace operations, you had to separate yourself with other vehicles. Then you had to have spacing, so that's buffer among vehicles, so that you don't get into a problem of separation. And typically, people joke about in the manned aviation, the separation standard en route is 5 miles. Closer to airports is different. Over ocean is 30 miles, and then there is some buffer allowed. And that depends on how much mortgaged air traffic controller has. So there's a little bit of extra spacing, and that accommodates for wind conditions and changes and such uncertainties. Then you schedule. You really don't want everybody showing up at the same time. So you want to schedule a constrained resource. For example, San Francisco Airport has 65 arrival rate per hour. Well, you don't let 130 come at one time. So you have to schedule them so that it's manageable for air traffic controller. Then, which is the demand capacity coordination occurs. When you have excess demand or capacity, you need to do some rationing, so to speak. Then you need some services for weather, understanding, tracking where exactly they are, and creating trajectories that are efficient. 20 minutes left, okay. And then at the top, this top level FAA sets up the constraints in the airspace. So that's sort of the basically bubble chart here that shows you need to have all these services, and the UTM environment, some of these services can be provided by third parties. So you all have an opportunity to say, well, I'm going to create system for spacing or weather or tracking them. So there's typically, this is FAA, a navigation service provider. You got a service supplier, you could be one of them. Then there's Air Mobility Operations Center, sort of network operations center. If you are a fleet operator, then you have your own network. You're checking out the contingencies, you're making sure that all operations are efficient, and there is some user demand that comes. And that drives how many aircraft are going to be, whether it's drones or personal air vehicles, such. So now, going towards urban air mobility, how do we transition to that environment? Clearly, you can't say, I'm going to put 100,000 urban aircraft in New York City or San Francisco all at once. So, as I mentioned, aviation is very evolutionary environment. So, as much as we like to promote aviation and innovation in the aviation, we still have to respect that safety traditions that we have long enjoyed. So we propose a crawl, walk, run approach where you still can take low density, start with low density operations, helicopter routes. So this is Dallas, Fort Worth. There are 2, 4, 5, 6, 7 runways there. And you could have basically helicopter routes. Dallas Fort Town is here. You could have, so either from here or anywhere else on the corners, they can bring in helicopter routes and come as close as possible to the terminal, so that if you are avoiding road transportation, you are able to take the air taxi, so to speak. You can get there and then land close to the terminal and then go to your terminal. That's sort of the idea. So you start with helicopter routes, then the controllers have to give clearance into the controlled airspace. UTM environment that we saw for drones can be extended here so that they operate, and you have a pre-approved clearance to get into the airspace and then go as close to the terminal as possible. And users will create their own trajectories and their own tracking and such to stay away from what is going on in the manned aviation. Typically, the aircraft come in and out of the airport this way. So if you are away from the manned aircraft profiles, then you are able to maintain your operations uninterrupted manner. So that's sort of the beginning, using the helicopter routes. Then you go towards medium density, because the scaling is going to be very important. To have a good business model to work for urban air mobility, you need to have constant churn of these vehicles and operations. Then again, user will create conflict-free trajectories. They will interoperate and share the intent through UTM kind of characterization, and they will do their own management of detection of conflicts and contingencies and such, which today are dependent on coordination with air traffic management. It's all about managing contingencies in off-nominal situations so that you don't overwhelm the ATM system. Then the last one is high-density mature operations, where it's fully automated. Everything is done autonomously, planning, scheduling, separations, entry and exit out of the controlled airspace. And the other part of that is multiple vehicles that might take off and land simultaneously at these buildings. So you have vertiport with multiple vertipads. So one of the discussion point is how close should I put these pads together based on the downwash and the ground wash of the vehicles as they are moving. As you probably have experienced, if you're close to a helicopter, you see that basically wind effects. And that's basically an important point of understanding how close you can put these pads so that the arrival departures can simultaneously take place without interfering with each other. So there is a research needed, there's a tool needed for a vertiport real estate operator to build these things, to say how close I can put them, what would be the effect on people going in and out, what's the entry and exit. So it's really one of the needs that your small businesses can look into. But nonetheless, much research is needed to identify the requirements for these scaled operations as we look into the future. Then extend that paradigm even further. So let's look at what will happen in the future. So there is going to be commercial space operations over 120,000 feet. There's going to be the Google Loon and Facebook Aquila and a whole bunch of other operations that will happen 60,000 feet and up. Supersonic operations could happen in the same airspace. Then this is our conventional airspace, class A, B, C, D, which is, if you don't know the classification, roughly it's 18,000 feet and up is class A, up to 60,000 feet, which is where there are some requirements on the vehicle as to what needs to have on the vehicle to enter into that airspace. And then there is the personal air vehicles, the space that I mentioned, on-demand mobility going into the urban airspace, and the drone traffic management. So the idea here is we started off with the drone traffic management, as a construct. But what it is a cooperative traffic management where you exchange information about your intent and share information about your operations and stay away from each other, rather than having to send in your information, get someone in the middle to say, okay, this is a free trajectory, you can go. So this is done much more collaboratively. There are no services provided by FAA or any other organization in the world as well, 60,000 feet and up. So we want to extend the UTM paradigm from low altitude to high altitude to as well as the space traffic management, orbital traffic management. So that's another basically opportunity. And as we slowly capture this airspace in terms of new paradigm, we see an opportunity for the current manned aviation operations to say, okay, let's also go towards service-oriented architecture rather than depending exclusively on the middle person, air traffic control system and the operator. So that's sort of the idea. We're going towards new paradigm. We start here, go high altitude. The high altitude allows us to go across nation boundaries. The low altitude is going to be, the drones are going to be primarily confined to regions because their range is limited, 45 minutes, maybe 2 hours in the future, maybe 4 hours, but largely they will be inside regions. But the high altitude, the loons and Aquilas, they go across national boundaries, Virgin Galactic. And the space, of course, goes all over the place. So we want to take that paradigm and populate it other places where there are no services. It's sort of an opportunity where to create something. So we are going to use the new paradigm and then slowly figure out how to get to the current airspace. So the current ATM system and the new UTM-inspired ATM, you can see all the services are provided by the FAA. You can see that humans address off-nominal conditions and contingencies. Human is at the epicenter of the information integration. Everything goes through FAA system. Every data goes through FAA system. Every change is approved by air traffic controller. Very little interaction among users and third parties. So going towards a new paradigm, only some services will stay with FAA, particularly directives and constraints. Everything can be pushed out into the third parties, flow management, sequencing, spacing. Some people argue separation also. So you have all these new users and the old users work together collaboratively, and automation becomes the epicenter. One of the foundational research and the product line that needs to be done is automation has to address off-nominal conditions and contingencies. If you depend back on the human to manage contingencies and off-nominal, then the model doesn't scale. Then you're back to where we are here. So now there is a huge opportunity for all businesses, small, large, medium, to figure out what kind of automation we need to manage these contingencies. So automation really is epicenter of information integration, and its paradigm is much more digital, much more connected with different apps from outside, and that promotes the scalability. So we have our role, which is figuring out architecture, the exchanges of the data, roles, responsibilities, service allocation, the performance standards and such. And that's what our research is going to be focused on. So why do we need that? Is basically the current system doesn't scale. All interactions go through a FAA system, and it doesn't leverage anything that's happening outside. So the costs are all borne by government. Modernization is a slow process, and it doesn't accommodate new entrants very rapidly. So that's why we need to change. So our changes will be the methods, techniques, interaction among operators, the whole architecture, and the services that you will be supplying to these operators. So what's the next thing? As I mentioned, we really want to see a complete paradigm change, one towards service-oriented architecture for everything that we're learning from UTM, the low altitude, and going towards high altitude, extension of UTM into the urban air mobility operations through cooperative data exchanges, and then very high altitude, 60,000 feet and up, where again the same construct can be used. So we have very active collaboration with the industry. We have, for UTM, we have over 200 collaborators to the industry. we have very simple process. They've basically replied to RFI, and every time we have a field test, working group meetings and such, they are invited and they get to participate. The construct has been adopted globally. What we started, Japan has JUTM, Korea has KUTM. They're all following a model, SBIR, which is the Single European Sky Initiative, ICAO, which is the International Civil Aviation Organization, Singapore. Everybody is basically following UTM paradigm. There is no competition for that. So you're safe. If you bring any technologies related to that, you have an opportunity to make impact. We have pretty good tight connection with FAA, who are the implementers and operators of the airspace. So we have something called Research Transition Team, RTT. It's on the website. You can take a look at that. The next step for us is to do the pilot program with FAA and start the operations at a larger scale, slowly. And as I mentioned, we want to evolve this paradigm to the larger airspace. And now this is where I'll stop, allow you to ask questions and take comments. Thank you.
Any words on cybersecurity, hacking?
We have cybersecurity work group. Yeah, definitely important. There's more work needs to be done.
How does the whole construct you presented interface with the division between VFR and IFR, visual flight regime and instrument flight regime?
So this is similar to replacing VFR with electronic means by cooperative exchanges and staying away from each other. If you want to go into the IFR airspace, then you are, so if the drone, for example, is wants to operate in uncontrolled to control, which is VFR to IFR, then they're dual capable, is one model. So if you stay inside, if you always operate under VFR or uncontrolled airspace, then you only confine to the UTM data exchanges. But if you're only operating under controlled airspace, you confine to whatever standards they have for IFR. If you are going back and forth, then you confine dual. So you're dual capable. That's sort of the elegant solution we came up with. Rather than forcing everybody into uncontrolled airspace to get equipped like controlled operators. Didn't make any sense because it requires coordination through centralized body, and we're not interested in keeping the centralized system much more cooperative.
PK, you hear me? Is this on? Is this on?
Yeah,
it's on. Excellent presentation. I'm glad I sat in on this. First of all, when you mentioned,
glad you sat in on it.
When you mentioned 7 million drones flying by year 220, my body resonated. I thought, what a fantastic market. I mean, anybody developing software or some sort of solution, you've got 7 million customers, and it's probably magnified or leveraged by the hundreds. So it is a good opportunity for small business. My question is, you mentioned a lot of problems to be solved for this all to be implemented. And these are good topics for small business. Are those outlined in an existing subtopic in SBIR? Or I have to admit, when I read your section in the handbook, I kind of glassed over it, but I was just wondering if you were aware.
So I now know that in the night you're going to go home and read that thing.
Yeah, I'll read it
that you
for
glassed
sure.
up.
But if it isn't covered, if some of those things aren't covered, I didn't.
Well, so what I would say to that is, I think folks who are interested in that, last year we had UTM topic in the SBIR.
Right.
So that's given. Whether that will continue or not, I don't know. That's up to the SBIR people. But I do know that there is a huge interest from the industry and FAA and a global level about the UTM. So I hope we continue the UTM topic.
Well,
now they can read the UTM CONOPS paper, our research findings from TCL 1, 2, and that will give you more ideas. I mean, the paper, reading SBIR topic write-ups is good, but that's only whatever pages, paragraphs. I think if you are serious about this, I would say you study what our paper publications are. They're all on the website, by the way. aviationsystemsdivision.org.nasa.gov. If you go to that website or just do NASA Ames code AF, you will see that website. There are a lot of papers. We publish everything that we do, and it's on, whatever we publish, it's on that website.
Well, the other part of that equation, though, is that we have to make sure we have subtopic managers that are champions for this, so that when proposals do come in, they're the ones that are reviewing these proposals, and we get some of these things funded.
Yes, all I can tell you is I was involved in reviewing one of the reviewers, and I managed 2 SBIRs last year myself, and one of them went into SBIR phase 2. So I am very committed to this whole body and I put a lot of time in reading proposals and mentoring some of the businesses. So I enjoy that. A lot of good stuff happened. This is my probably 15th year doing SBIR topics.
And so as the ARMD Mission Directorate rep, I can assure you that we are kicking off our solicitation development process this week, in fact. And so we're working hard to make sure that the new directions that are being defined within the programs and within ARMD are going to be reflected in this. So there will either be new subtopics on these areas, or the existing subtopics will be broadened or refocused. So you have to be, read them. So just make sure you read the new solicitation when it comes out, because there will be stuff in this area.
We have 1 minute to go.
Well, I'll just tell you a success story. So last year we had 2 SBIR phase 1s that I was managing. I was hoping both of them will get through phase 2. One of them got through, and they're getting additional funding from another entity. So we just awarded it, and we're looking at phase 3 already. So this is a hot area, in general. So. If your passion permits to go into this, I would say go for it.
We have a question online, but we need some clarification, so we may not get that on time. But we'll definitely pass it on to add to the notes.
Okay.
Any other questions from the participants in the room? Then I guess that concludes our last fabulous technical presentation for the day and the event. Thank you so much.